The third option that we've seen out there is this engineer automated simulation. And again, this is where an engineer is working on their own, independent of any analyst. The idea here, however, is that there's been an automated simulation workflow that's been developed and designed by an analyst, an expert analyst who has the expertise to develop these things, right? So there are standard inputs for these in terms of different, not only the model geometry, but also things like, well, where is this held? Where is the load applied? So you designate certain geometric parts or places where that's going to be used. Now, this setup is commonly run on networked computers, so you can leverage high performance compute clusters and things like that. It is also run in the cloud. And the same type of thing happens here. You look at a number of different options. So this is an option that's emerged in the last, I would say the last 5 years to a greater degree. They've been around a little bit longer than that. We can go back, for a decade, maybe 15 years that this type of technology has been around. But this concept of, hey, we're going to develop a application-specific workflow or automation. And when I say application-specific, it's looking at, okay, NVH in the interior of a car, fluid flow cooling for electronics. And the scenarios, the workflows that you set up for those really aren't applicable anywhere else. You can't take the cooling analysis and apply it somewhere else. There are certain inputs. It's designed to have a certain output. And these get really, really specific because the solver matters, the mesh density matters, and that's the stuff the expert analyst is kind of setting up this workflow to apply to. So this works if you have very specific scenarios, if you want to enable your engineers to look at a lot of different options. So that's the application there.